Hello students, welcome to the class. Students, today we will be learning about the components or the constituents of the air. So first one is the nitrogen. So students, as I have told you in the class also, that nitrogen is the most abundant gas that is present in the air, and it constitutes about 78% of the air, and it is of odorless, colorless and tasteless gas, and it does not support the combustion, neither it is combustible, that is, it does not burn, neither it helps in burning, and it is a non-poisonous gas, and it is soluble in water. And when the temperature of the gas is lowered as low as minus 196 degrees Celsius, then this gas can be easily liquefied. Now, what are the uses of nitrogen? So students, it is used to slow down the activity of the oxygen. As we say, oxygen is a supporter of combustion. So when we burn something, oxygen is required, but it is the nitrogen that controls that burning. If nitrogen was not there, then everything in the atmosphere, everything in the earth would burn. Okay, so that is the nitrogen, this gas nitrogen, that controls the burning. And it is also very essential for the plants and the animals, because it helps in the protein formation. Now, but this nitrogen cannot directly be absorbed from the atmosphere. So what happens is that there are certain plants which have this capability of what we say, fixing this atmospheric nitrogen in the form of nitrates and nitrites, and these nitrates and nitrites are absorbed by the plants, and these plants are eaten by the animals. Okay, so whatever product we are eating from the from, be it vegetables or be it fruits, we are getting the protein, amount of protein from it. Or when we eat the meat, we get the protein, because that nitrogen is now converted or made into the protein. It also helps as a cooling agent in the industries and in the hospitals. This nitrogen, liquid nitrogen, at a very low temperature, it is used to store the uh, organs of the bodies. Like you might have heard, transplantation, liver transplantation, transplantation. So in those cases, what happens is that we use the liquid nitrogen. Now, large amounts of nitrogen is also used to make the fertilizers like potassium nitrate, ammonium sulfate, etc. And this is the inert gas in the nature, and it is used for filling up the food packages. Apart from this, this gas nitrogen is also used for the manufacturing of ammonia and nitric acid, and we already know that these ammonia and nitric acid, how valuable they are and how useful they are for the industrial purposes. Apart from that, nitrogen can also be used for making the explosives like TNT, that is trinitrotoluene. Now we have the oxygen. Students, we all know how important this second constituent, which is oxygen, how important it is. It is the second most abundant element on the earth, and it constitutes 21% of the volume of the air, which is the oxygen. And we cannot live without oxygen, because for the respiration we need the oxygen. Now, it was prepared by a scientist by heating the mercury oxide. Now, if you see, this is HGO, mercury oxide, and this is the liquid mercury. So he used this convex lens, and he heated through with the help of sunlight. He heated this mercury oxide, and then what happened is that when he heated this mercury oxide got decomposed into mercury and oxygen. And if you see here, the level has decreased. That means this liquid mercury is now moving upwards, and here this area is occupied by the oxygen. So that is how he prepared a colorless, odorless and a tasteless gas, that is oxygen. And in the laboratories, how we can prepare, what we have to do is we have to heat this hydrogen peroxide in the presence of manganese dioxide, and then it will get decomposed, which is H2O2, the formula for hydrogen peroxide, which will get decomposed into water and oxygen. So that is how we prepare the oxygen in the laboratories. Now students, what is the procedure? Now if you see, manganese oxide is taken here in a flask, round bottom flask, and a stopper is fixed there. So, and it has two holes of through one thistle funnel is connected, and the other through the other one delivery tube is connected. And in this thistle funnel, hydrogen peroxide is taken, and it is taken down into the flask drop wise drop. So when it comes in contact with the manganese oxide, then a brisk effervescence is seen. And we know that brisk effervescence is the characteristic of the evolution of the gas. So now this gas will pass through this delivery tube, and it will come here in this beehive shelf. And now you will see that the bubbles will start coming up here, and oxygen will get accumulated here, and the water will go downward. So that is the downward displacement of the water, and in this trough the level of the water will increase. The students, next up we have is the preparation of oxygen from the compounds containing the oxygen. So students, there are many compounds like mercuric oxide, potassium nitrate, lead nitrate, potassium chlorate. They all contain the oxygen. So when we will decompose them using heat, or when we will heat them, then they will decompose or they will decompose giving us the oxygen. Like if you see here, we have mercuric oxide. So when it is heated, if you see here, this is mercuric oxide, red colored mercury oxide. When it is heated, what will happen? It will dissociate into mercury and oxygen, and this oxygen will escape from this test tube. So when you will bring a glowing splinter here, it will it will rekindle, or you will see it start glowing, and this is a confirmatory test for the evolution of the oxygen gas. Now students, thermal decomposition of potassium nitrate. How we can produce, or how we can generate the oxygen gas by the decomposition of potassium nitrate. So students, the formula for potassium nitrate is KNO3. That means it contains oxygen. So when we will heat this potassium nitrate, which is a white colored crystal substance compound, then it will turn into potassium nitride and will give us oxygen. And this oxygen again is the colorless and the odorless gas. And we know that when we will bring a glowing splinter near the mouth of the test tube, then it will start glowing, which is the confirmatory test for the evolution of oxygen. Now students, the other methods, or you can say thermal decompositions of other compounds. So students, here we have is the lead nitrate, which is PbNO3 whole twice. Again, it has the oxygen in it. So students, when we will heat this, then it will give us the lead oxide, nitrogen dioxide, which is a reddish brown colored gas, and apart from that it will give us the oxygen. So again, what we have to do is we have to bring the glowing splinter, and you will see that it starts glowing again. When you will bring the splinter, it will start glowing, which is the confirmatory test for the oxygen again. And the residue, which is the reddish brown in color, when it is hot, but when it is cooled, after some time it will turn into yellow. Now students, if you see here, we have potassium chlorate, KClO3, which again has oxygen. So when we will heat this in the presence of manganese dioxide, which is a catalyst, then you will see we will get potassium chloride, which is KCl, and the oxygen. Apart from that, red lead, which is Pb3O4, when it is heated, it will give us lead oxide, oxygen. And when lead dioxide, which is PbO2, when it is heated, it will dissociate into, or it will get decomposed into lead oxide and oxygen. Likewise, silver oxide, which is Ag2O, when it is heated, it will turn into silver and oxygen. And students, we can confirm this the evolution of oxygen by bringing the glowing splinter, and it will confirm the evolution of the colorless and the odorless gas, which is the oxygen. Students, here are some tests for the oxygen. We all know that it is a colorless and odorless gas, and it has no effect on the moist red or blue litmus. That means it will not turn the moist red litmus into blue, or blue litmus into red, because it is neutral to litmus. And as we have been studying, that it relights a glowing splinter, which tells us that it is a supporter of combustion. And apart from this, oxygen produces brown fumes of nitrogen dioxide when we will bring it in contact with the colorless nitric oxide. And oxygen gas also turns alkaline pyrogalol solution brown. So these are the tests for the oxygen. Students, these are the properties of the oxygen, and we know that it is colorless, tasteless, odorless gas, which is also a non-poisonous gas, and it is slightly soluble in water. And that is how the aquatic plants and animals survive in underwater, because they use the dissolved oxygen, the oxygen which is which is present in the soluble form in the water. And when we will lower the temperature to as low as minus 183 degrees Celsius, and when we will expose it to the high pressure, then it will get liquefied into bluish colored liquid oxygen, which also has industrial uses, and it is also used in the hospitals. Now vapor density, it is slightly heavier than the air. The vapor density of oxygen is 16 and that of the air is 14.4. So if you see, it is very slightly heavier than the air. So these are the physical properties of the oxygen gas.